Hello students, in this video lesson we're going to be going over a topic in math called matrices. And if you are placed into an advanced algebra course in college or even a math course called linear algebra, you're going to be using matrices. Now, what exactly is a matrix? Well, here's the definition. A matrix is just a rectangular array of numbers. So here is an example of a matrix. Matrices are named using capital letters. So this particular matrix is matrix A. And matrices are just rectangular arrays of numbers. The plural of matrix is matrices. So if you have more than one, you have two matrices. And a matrix is just a rectangular array of numbers. Right now, the numbers inside of these brackets are kind of arbitrary and just given to you. But eventually, those numbers will have meaning. They will have value. The next definition is what we call the dimensions of a matrix. And the dimensions are just simply the number of rows and the number of columns in the given matrix. Rows work horizontally, columns work vertically. So here are two matrices, and I want to find the dimensions of these two matrices. So look at this first matrix. This particular matrix has 2 rows, and it has 3 columns. So we say the dimensions of this first matrix are 2 by 3. We read this as 2 by 3. You always have the number of rows followed by the number of columns. So we say this first matrix is a 2 by 3 matrix. Those are the dimensions of that first matrix. Here, the second matrix, how many rows does it have? Well, this second matrix has 1, 2, 3, 4 rows, and it has 1 column. So we say that second matrix is a 4 by 1 matrix. So the dimensions are just simply the number of rows followed by the number of columns. The numbers inside of a matrix are called the entries or the elements. And oftentimes when you're dealing with matrices, you're going to want to single out a particular value inside of the matrix. For example, here's a matrix, and I'm asking you what entry is at the second row, third column spot. Well, here, the second row, so here are our 2 rows, so this is our second row. Third column, well, we have the first, second, third column. So the second row, third column value is the number 1. And a lot of times we're going to need to point out one of the values inside of the matrix, and this is how we do it. It always goes the number of rows followed by the number of columns. Now, your calculator has an entire menu devoted to matrices. If you notice, if you look above the x to the negative 1 power button, that inverse button, you see that there's the word matrix. So the matrix menu is located by pressing second and then the inverse button, second and then the x to the negative 1 button. Now when you do that on your calculator, this is what your screen should look like. What I want to do is I want to show you how we can go about storing this matrix into our calculator. So what I want to do is I want to store this matrix, and I want to call this matrix A. So after you press the second and then the inverse button, I want you to move the cursor to the right twice over to where you see Edit. And notice matrix A is highlighted. So move the cursor over to Edit and press Enter. Your calculator should now look like this. What it's doing is it has the cursor over this first value 1, and it's blinking. And the calculator is asking you the dimensions of the matrix that you want to store into letter A. Well, what are the dimensions of this matrix A? Well, matrix A has 2 rows and it has 3 columns. So matrix A is a 2 by 3 matrix. So what you want to do is just simply type over this 1 and change it to 2, and then type over this 1 and change it to 3 for a 2 by 3 matrix. When you do that and press enter, this is what your calculator should look like. So this is what your calculator should look like, and now what you're going to do is you're just simply going to type in these values for matrix A. After you type in 2, press enter, then type in 0, 7, -4, 5, and 1. So you want to basically store this matrix into matrix A on your calculator. Now go to the main screen of the calculator, so press second and mode to quit. And when you want to recall matrix A now, what you can do is go back to the matrix menu, press second and then the inverse button. It'll bring you back to this screen, and now while the cursor has names highlighted, notice number 1 matrix A is highlighted, just press enter, and what it will do is it will look like this on the home screen. It'll say matrix A, and then when you press enter, it'll just print this matrix on the home screen. So your calculator should look like this. And if you are using matrix A in many different computations, and I'll show you what I mean in terms of computations in a few minutes, this is what you want to do. You want to use the matrix menu to store and save the matrices and then recall them when you need them. If you're just going to use a matrix once, maybe do a computation on it and then ignore the matrix forever, there's another way, which I think is a little bit more convenient, in which you can enter a matrix into your calculator. What you can do is you can press the alpha and then the zoom button. When you press alpha zoom, what's going to happen is your calculator will give you a matrix template in which you can enter your matrix in another way. So by pressing alpha zoom, notice above the zoom in green is F3. This is the alpha F3 menu. And what it will allow you to do is to simply type in the dimensions that you need for your matrix. Remember, matrix A was a 2 by 3. So what I'll do is I'll adjust this column number down to 3. Then I'll move the cursor down to where it says OK. And what the calculator will do is it will give you an empty 2 by 3 matrix on the home screen of the calculator. So after going to alpha zoom, typing in the dimensions that you need just by moving the cursor up and highlighting whichever number that you need, here we're entering in a 2 by 3 matrix, your calculator should look like this. Your calculator gives you an empty 2 by 3 matrix with zeros as placeholders, and now what you're going to do is just simply type in the values that you need for matrix A. The only catch is when you type in each number, so I'll move the cursor here, that's where it starts, and I'll type in the number 2, you don't want to press enter. What you want to do is you want to press to the right to move the cursor over here and type in this case 0, which means I don't have to do anything. Then I'll press to the right, move the cursor here, and type in 7. If you press enter, your calculator will then save the matrix that you have when you press enter before you had the opportunity to type in the entire matrix. So I typed in 2, I pressed to the right to get to 0, but since that's already 0, I pressed to the right again. Now in this upper corner, I'm going to type in 7. You basically maneuver around this matrix template by using the arrow buttons on your calculator. Now I have matrix A typed into the home screen, and then when I press enter, all the calculator will do is then just kind of have this matrix on the main screen of your calculator. And here's what your calculator should look like. I tend to prefer this alpha zoom matrix template way of typing matrices into my calculator, especially if you're only going to use a matrix once. You can simply type in the matrix problem that you have. And I'll show you an example of matrix problems in a few minutes. If you're using the same matrices over and over and over again, then you should use the second inverse matrix menu to store and save the matrix. Now we're going to discuss how you add and subtract two matrices together. And here's the rule that I want you to copy down. It's only possible to add or subtract matrices if they have identical dimensions. You must have the same quote-unquote size matrices to add and subtract. And if you do have the identical dimensions, what you're going to be doing is you're going to be working with the corresponding entries, the corresponding values. So look at this first question that we have here. Here we're going to take this first matrix, which we stored into our calculator as matrix A, and we're going to add this second matrix. And both of these matrices are 2 by 3 matrices, so we do have identical dimensions. So what we can do is this. We can add the corresponding values. We could add the 2 and the 4 together, the 0 and the -8 together, the 7 and the 1 together, to get a brand new 2 by 3 matrix. Or what we can do is use our calculator to add these two matrices together. Since I have this first matrix on the home screen of my calculator from before, what I'll do is I'll press second and then the negative button to recall the previous answer, which is that matrix. Then I will press plus to add this other matrix. Since I'm only using this matrix once and then I'm done, I'm going to use the alpha zoom matrix template. I'll have my calculator set up another 2 by 3 matrix, press OK. And now what I'll do is I'll manually type in this second matrix into that 2 by 3 template. Then I'll just press enter, and then my calculator will add those two matrices together. And here's my answer matrix. Notice the 2 plus the 4 gave me the 6 in the first row, first column spot. 0 plus -8 gives you -8. So the way you add and subtract matrices together is you just work with the corresponding values. I find a lot of times it's very easy to make careless mistakes with matrices because of all the details of all the numbers. It's very easy to lose a negative sign. So you just want to be very, very careful when you type in the matrices. Take a minute. Try to do this second problem on your calculator. Here, I'm giving you a matrix that has 2 rows and 1 column, and I'm trying to add that to a matrix that has 2 rows and 2 columns. So I'm going to use the matrix template. I'm going to use the alpha zoom button to type in these two matrices on the home screen to perform this addition. Take a moment and do that on your calculator and take a picture of the results. Because we're only using these matrices once, I suggest you use this alpha zoom technique. You could also store these matrices into your calculator. Maybe you can store this first matrix as letter B and the second matrix into letter C and manually add the matrices that way. But since we're only using the matrices once, the more efficient technique is just to use the alpha zoom, set up 2 matrices, a 2 by 1 and a 2 by 2, type them into the home screen on your calculator, and then press enter. This is what should appear on your calculator after you press enter. Your calculator is giving you an error message that says dimension mismatch. And that's because the rule said you're only allowed to add or subtract matrices together if they have the same dimensions. Here you're adding a 2 by 1 by a 2 by 2, so you get this error message, which means your answer, which you would write for a problem that looks like this, the answer would be undefined. This addition is undefined mathematically. So the rule to add and subtract matrices is that you can only add and subtract them if the dimensions are the same. Next, the definition and a rule for you. A scalar is just a real number. So here I want to take the scalar, the number 3, and multiply it by this matrix. And the rule that you're going to use to multiply a scalar by a matrix is you're simply going to multiply the scalar by every entry in the matrix. So here we're going to take the number 3 and just simply do a really big distribute problem and distribute the 3 to every number in the matrix. Now you can do this on your calculator. Here I have matrix A. So basically I'm just having my calculator take 3 times matrix A. And here's how we can do that on our calculator. Go to the home screen, type in the number 3 and then times. Now let's go to our matrix menu. Let's press second and then the inverse button for the matrix menu. Since matrix A is already highlighted, just press enter. The main screen of your calculator now says 3 times matrix A, and then when you press enter again, it'll do the multiplication for you. So this is the picture that I want you to include on this assignment. So that's how you multiply a scalar by a real number. Now what I would like you to do is use your calculator to complete these 4 exercises. Here we have the same matrix A, but now we're given matrices B, C, and D. Here we're using the matrices over and over to answer some questions. So if this would appear on a homework assignment or an exam, you can do this in one of 2 ways. I would, since I'm using the same matrices over and over, go to second and then inverse, store these matrices into the memory of the calculator. I already have matrix A stored into the memory. I'll program in matrix B, C, and D. Remember how we do this. Go to second and inverse for matrix. Move the cursor over to edit. Now move the cursor down to matrix B. Press enter. Change the dimensions of matrix B to a 2 by 3 matrix and just simply store in the values for matrix B. Do the same thing for matrices C and D, and then we'll complete the problems. Remember, as you go about storing these matrices in, after you type in each entry, each number, press enter. Double check and make sure you didn't make an error entering in the numbers. Then go back to the matrix menu. Move the cursor over to edit and then highlight letter C for matrix C. Do the same thing for matrices C and D. Again, my advice is if you're using the same matrices over and over, store them into your matrix menu And now to complete these problems, all we really have to do is just type in the actual questions. Usually it's quicker to use the alpha window template, but if you're using matrix A over and over and matrix C over and over, it's better to store them. One disadvantage by using the alpha window matrix template is that you're only allowed to have up to a 6x6 matrix. When you are using the matrix menu, you are allowed to enter in much bigger dimensions for matrices. Once you have all 4 matrices stored into the memory, now to access each matrix, just simply go back to second and inverse and type in exactly what you see. So here I want to do matrix A, so go to second and inverse, choose option 1. Then I want to add matrix B, so then go back to matrix, move the cursor down to number 2, have your home screen match the problem. So here's problem 1, matrix A plus matrix B, then press enter to get your answer. It may take you a few minutes just to get comfortable with the sequence of buttons, but here is your answer for problem 1, matrix A plus matrix B. Take a minute, do problems 2, 3, and 4, take pictures of your calculator and include it on the assignment. Notice matrix A plus matrix B is the same as matrix B plus matrix A, so matrix addition is commutative. Problem number 3, you're being asked to subtract matrices that have different dimensions, matrix A and matrix C. Your calculator gives you an error, but you're not going to write error as your answer. You're going to write the word undefined for problem 3. And then for problem 4, you can just simply type in 5 and then the matrix C, or you can type in 5 times matrix C. Either way, you get your answer. Finally, I would like to discuss with you the rule for multiplying 2 matrices together. And the rule is, it's only possible to multiply 2 matrices when the number of columns of the first matrix, that has to be the same as the number of rows in the second matrix. So I want you to copy this rule and have it on your assignment. I'm not going to show you how you multiply matrices together. That's going to be in a future lesson. I'm just going to go over the rule of when you can multiply. So the question is going to be, is it possible to multiply these matrices together? So right now, our answer is either going to be yes, it is possible, or no, it's not. So take a moment, have the rule. It's only possible to multiply 2 matrices together when the number of columns of the first matrix, that has to be equal to the number of rows of the second matrix. So look at our first problem here. Here I'm asking you to multiply these 2 matrices together. These matrices have 2 rows and 3 columns. So here we're multiplying a 2x3 matrix by another 2x3 matrix. And I suggest you write out the dimensions above each matrix. Now what has to happen? It says the number of columns in the first matrix. Well, the first matrix has 3 columns. So the number of columns in the first matrix is 3. That has to be the same as the number of rows in the second matrix? Well, the second matrix has 2 rows. So the only way you can multiply is if the number of columns of the first, that has to be the same as the number of rows of the second. So is it possible to multiply this first problem together? No, this would be an example of an undefined operation. It's unusual. You could add these 2 matrices together because they're both 2 by 3 matrices, but you can't multiply them together. Look at the second problem. Write out the dimensions of each matrix. The first matrix has 2 rows and 2 columns, so that's a 2 by 2 matrix. The second matrix has 2 rows and 3 columns, so that's a 2 by 3 matrix. So can you multiply these 2 matrices together? Is the number of columns in the first, that's 2, is that the same as the number of rows of the second, which is also 2? Yes, these 2 middle numbers match, so you can multiply these together. How do you do that? Well, we're going to use a calculator to check this, but right now the answer is yes. Is it possible to multiply? Take a moment. Try to see if you can multiply these 2 problems. I want you to first write out the dimensions of each matrix and see if the rule holds true, see if the 2 middle numbers match. And then I want you to verify by using your calculator. I want you to try to type in the actual problem and see what the calculator says are your answers. Take a minute. Try to do each of these questions on your own. You can either store the matrices into your matrix menu. The way you edit a matrix, if you want to let this first matrix be matrix A, all you do is you go back and you edit the matrix that you have there to match the matrix that's given to you. This first matrix, its dimensions are 3 rows and 1 column. So if you want to store matrix A into your calculator, you'd have to set up a 3 by 1 matrix. Here the second matrix has 1 row and 2 columns. So that's a 1 by 2 matrix. So you can either store the matrices into your calculator by editing previous ones, or since we're just doing these questions once, using these matrices once and then moving on, I suggest to do these questions, you use the alpha window matrix template to do these problems on your calculator. The first problem, you're multiplying a 3 by 1 matrix by a 1 by 2 matrix. Here the number of columns of the first, 1. That has to be the same as the number of rows of the second, which is also 1, so the 2 middle numbers match. So the answer to this question is yes, they can be multiplied, and then when you multiply them together, this is what your calculator gives you. It's odd. You're multiplying a 3 by 1 matrix by a 1 by 2 matrix. What are the dimensions of your answer? Your answer has 3 rows and it has 2 columns. So your resulting matrix is a 3 by 2 matrix. Look at the second problem. Here you're multiplying a 2 by 3 by another 2 by 3. The number of columns of the first, 3. That has to be the same as the number of rows of the second, 2. Here the 2 middle numbers match, so no, these problems can't be multiplied. These 2 matrices can't be multiplied. If I asked you what the answer was, you would write undefined. Right now, I'm just more concerned about you being able to do the problem. Now, I know what you're thinking. Is the video over? Shortly. But why can't you just not worry about the rule and let your calculator tell you if it's undefined or not? Well, what's going to happen is, and this is where I'm going to leave you, is this. Here I want you to try to multiply these 2 matrices together. Here we have a 3 by 2 matrix times a 2 by 2. The number of columns of the first does match the number of rows of the second, but if you notice in these matrices, you have variables, and you're not going to be able to type in variables into your calculator. You're going to have to know the process of matrix multiplication, and that's where we're going to pick up in future lessons and videos.